Salutations, Godzilla. How did your engineering midterm go?
It wasn't good. I failed.
What? How could you fail that after our big study session?
We had a study session?
Aw, come on, Godzilla. You're gonna fail the class.
Au contraire. My engineering teacher is going to give me a makeup test. He says my final can count as my midterm.
Oh, well, that's good. How long have you studied for your final?
Well, I was kind of hoping you'd help me start.
All right. What do you need to know this time?
I need to learn how to use visual and verbal communication to express basic design elements. I need to apply mathematics and science to a solution of a technological problem, as well as apply principles of science, technology, engineering, mathematics, interpersonal communication, and teamwork to the solution of technological problems. Also, Gigan, I have to solve problems using basic engineering tools and resources, and I have to apply engineering graphics and technical writing to communication of an engineering design. I must demonstrate the engineering design process, as well as demonstrate prototype development.
Well, that doesn't sound too hard. Why don't we start with an introduction to hydraulics and pneumatics? Here, I have a chart. As you can see here, Godzilla, hydraulics and pneumatics are two completely different things, and yet they share many similarities like pressure systems and shapelessness. We'll start with pneumatics first. As you can see on the double bubble map, pneumatics is a type of power transmission that uses a gas and pressure to create movement. Now, a pneumatic system contains a compressor, storage tanks, regulators, gauges, actuators, fittings and tubing, and valves, and solenoids.
And they each do something important in the system.
Exactly. The compressor converts electrical energy into pneumatic potential, and air tanks store pressure. Regulators adjust that pressure, and the fittings provide a quick release and pipe thread. Now, the valves and solenoids are used to control actuators. Now, there are two types of actuators. There are linear and rotary actuators. Linear actuators, known as cylinders, perform complex motions within mechanical components, and rotary actuators have limited rotation and are self-controlled like air motors or turbines. Actuators also have flow controls, like the check valve. Now, as I'm sure you've inferred, pneumatics are better for straighter movements, but they can be fitted for rotary movements.
That seems to be like a disadvantage.
Well, yes. Pneumatics has advantages and disadvantages. Some advantages are that pneumatics come in a complete kit. They weigh equal to or less than the alternatives, and they're just simple, durable and strong, and they're also adjustable and very easy to expand. And then we have the disadvantages of a pneumatic system. The disadvantage are a highly initial weight cost and fine-tuning requirements, and there's also limited uses within larger actuators.
Fancy dancy.
Yes, and if you also look on the bubble map, we have hydraulics right here. Now, hydraulics is the study of fluids, the study of water or other fluids at rest in motion, especially with respect to engineering applications.
So it's really just like pneumatics, but with liquids.
Exactly, Godzilla. Now let's get into hydraulic theory. Now, hydraulics cover the physical behavior of liquids in motion. They're pressurized oil used to get mechanical advantage, which is a big deal, and they help you do work. Hydraulics are shapeless, incompressible, and they're a great transmitter of force. Now, to fully understand hydraulic theory, you have to know Pascal's law. Pascal's law states that magnitude of force transferred is in direct proportion to the surface area.
So you mean pressure equals force divided by area. Or force equals pressure times area.
Well, technically it's said multiplied by area.
Whatevs.
Anyways, let's talk about a basic hydraulic system. A basic hydraulic system has hydraulic fluid, most likely it's going to be oil, and always has a pressure source like a hydraulic pump, and a pressure user, which would be your motor. Then there's always the piping system, Of course, you have to have some way to get the fluid around. Now, hydraulic pumps are very important. A pump can be positive in its displacement or centrifugal. Now, there's always the water pump, which is like a variable stroke piston pump. It's pretty neat. You see, it's a tilting box, and the angle of the tilting box determines the capacity and direction that the oil goes. Of course, on the other end of the system, we have the cylinder or the motor. Now, the piston, or cylinder as it's called, is used to make motion linear, and the hydraulic pressure moves the pistons. Also, the load is connected to the ram, like the rudder on planes or masts, periscopes, anything like that. Also, you can use the motor if you need rotary motion.
Okay, so the hydraulic pump is at the A end of the system, and the cylinder or motor is at the B end of the system.
That's correct, Godzilla. Next, we need to learn about the piping system. It needs to be able to withstand lots of pressure. And we need valves and filters. Those are all necessary. We also need accumulators. There are 3 types: the piston, the bladder, and the direct contact, which is the least common. The piston is the most common, and the bladder holds things like gun mounts and steering systems. Now, these accumulators, they hold the system under pressure and compensate for leaks. They also provide hydraulics when the pump is removed or lost.
Does a hydraulic system have advantages and disadvantages like a pneumatic system?
Why, yes it does, Godzilla. You see, some advantages are a convenient power transfer. There are very few moving parts in a hydraulic system. And there's not a lot of energy loss when you travel long distances. There's also flexibility. You can put force to multiple directions, and it's safe and you can use it many times, and it can be stored under pressure for good long periods until you need it again. They also have variable speed control, which is great if you have a quick response. Also, there are disadvantages. It requires positive confinement. Obviously, you have to give it some shape. And also, if you use something like oil, it's explosive or flammable, which can be extremely dangerous. So filtration is critical. It has to be free of debris. You don't want an explosion on our hands. Also, manpower can be intensive in cleanup. You're gonna need a lot of fellas to tote that stuff.
What are some good things hydraulics are used in?
Well, you always have the electro-hydraulic drive system. Hydraulic is right in the name. It uses hydraulics to take power from the electric motor and move it all the way to the load. They're rotary, and a good example of these is steering gear. Now, it's pretty good. It uses a hydraulic cylinder to produce linear motion, which is efficient, and the pumps connected by piping to the hydraulic ram center. Now, they have various methods for connecting rams to tillers, and 2 pumps for redundancy and reliability in case one fails.
Cool! Now let's cover mechanics so I can understand a single word you just said.
Alright, Godzilla, look at this brace map of mechanics. It breaks mechanics down into some of its basic components, like energy, motion, and friction, and then tells their parts. That way it can better help you organize and understand mechanics. Now, mechanics is the field of study that studies the role of energy and force and the cause of prevention of motion. And you already know some of its basic components, like energy or the ability to do work, motion, which is caused by the imbalance of forces, creating kinetic energy, and work, which is useful motion and commonly defined as the product of applied force and distance moved. Also, there's power, a measure of work, and torque, which is the effect of force acting on a specific distance from an axis of rotation in a rotary system. And then you have friction. It's the mechanical force that resists motion between 2 bodies in contact, like when you slide across carpet. Now, there are 2 types of energy: potential energy, which is stored or still energy, and kinetic energy, which is moving, energy with motion. And there are 3 ways that energy can be transferred. The first is by contact. By contact of 2 surfaces, like a golfer who uses a club to hit the golf ball. And the second form is when an energy difference exists between 2 objects, and the energy flows from one to another. The last method is radiation. That's the kind of energy that created you. It's in radio waves and light energy.
Sweet.
The 6 common forms of energy are mechanical, thermal, light, electrical, chemical, and nuclear energy. Now, to fully understand energy, you need to know the essential law of conservation of energy. This law states that any form of energy can be converted to another form of energy, but no energy can be lost in this process. It's like when machinery operates, friction makes a portion of the energy thermal energy. It heats up.
Of course.
Now let's talk about motion. Sir Isaac Newton developed 3 basic laws of motion. Newton's first law was the law of inertia. An object in motion remains in motion until something acts upon it, or an object remains in rest until something acts upon it. And then there's the second law, which is the relationship between an object's mass, acceleration, and applied force, or force equals mass times acceleration. Now, acceleration and force are vectors. In this law, the direction of the force vector is the same as the direction of the acceleration.
Fancy.
And then there's the third law. For every action, there is an equal and opposite reaction. Now let's discuss work. Work is a measure of mechanical energy. It's also a measure of force. You see, the work done by a constant force is the product of the force, the displacement, and the cosine of the angle. And energy and work are not the same, but the units are expressed the same way. You see, work is measured using this formula. W equals F times D times cosine. You see, the W equals work, the F stands for force applied, and the D stands for displacement or distance traveled, and the cosine is the angle at which the object is displaced from the horizontal position.
But what about power?
Well, power is the amount of work done. You measure power in watts, which is the metric unit, or horsepower if you want to use the English unit. You see, 1 watt is equal to 1 joule per second, and 1 horsepower is equal to 550 foot-pounds per second. 1 horsepower is also equal to 746 watts.
That's craziness.
Now we can't forget about friction. Friction is the mechanical force that resists the motion between 2 bodies that are in contact. You see, friction is always against motion, and it's always there when an object comes into contact with something like a solid or a fluid. You see, friction is greatest when objects are at rest, and since the acting force has to accelerate whatever is at rest to the velocity, it has to do that even more to overcome friction, or the rubbing action between surfaces. You see, friction force is smaller for fluids, but it's related to viscosity of the fluid. Now with gases, the friction force is like drag. Friction occurs in every mechanical device, by the way, and in machinery, the objective is to reduce friction, which reduces energy loss and makes your machine more efficient.
Does that apply for all 3 types of friction? Static, the largest; dynamic, the one with lesser magnitude and requires only sufficient energy to maintain motion between objects; or rolling, the smallest force?
Exactly, Godzilla. See, you're getting the hang of this. What do you need to know next?
Knowing about sketching would be swag.
What do you know? I just so happen to have this tree map for sketching.
Do you have a tree map for everything, Gigan?
You bet I do, Godzilla. Anyways, as you see here, there are 3 types of sketches: single view, multi-view, and pictorials. Single view shows a clear understanding of the major design idea. Multi-view have front view, top view, side view, many different kinds of views, and pictorials are isometric, oblique, and perspective. You know, Godzilla, the purpose of a sketch is to quickly and easily get your ideas onto paper so that you have them for later. Like design sketches, freehand technical sketches, technical illustrations, doodles, all kinds of stuff. Now, there are several sketching techniques you'll need to know, like proportion, clarity, and sketching aids.
I don't want sketching aids.
Now, I've already touched on the 3 types of sketches: single view, multi-view, and pictorials. Single view sketching is mostly used for technical purposes, like to show a clear understanding of your idea. They also are always front views, because the front has the most descriptive features. Then we have our multi-view sketches. They're technical sketches that show the front view, top view, and side view. Pictorial sketches are used to quickly communicate your ideas. They're 3 dimensions and in one view. They show the width, height, and depth, all in one drawing. Now there are 3 types of pictorial sketches: isometric, oblique, and perspective. Isometric drawings have 3 equally spaced axes of 120 degrees. And they show the height, width, and depth, just like all pictorial sketches. Now an oblique sketch is usually a front view, and it's drawn true shape and size. Now they have receding edges, usually drawn at angles of 60, 45, or 30 degrees. They also have circles and curves drawn on planes, so they will appear true when you see the size and shape.
That seems easy enough.
Now let's cover some structural engineering. As you can see here, at the middle of this circle map I made you, structural engineering sits. And then, all throughout the circle, there are things that go with structural engineering, like sediment loads. And then on the outside, there are several examples for the types of loads, like a fixed house that isn't moving, or a moving 18-wheeler. Now, as I'm sure you know, Godzilla, structural engineering is the science and art of designing and making, with economy and elegance, buildings, bridges, frameworks, and many other structures, so that they can safely resist the forces that they're subjected to. Now, there is a process for structural engineering. You have to determine your types and magnitudes of loads, and also their structural context. You have to generate alternative structural systems, in case yours fails, and you have to analyze one or more alternatives, select to perform detailed design, and implement your design. Now, you're going to have to work with several different types of loads, like dead loads, live loads, dynamic loads, earthquake loads, thermal loads, settlement loads, and wind loads.
I know what a dead load is. It's the weight of the structure, like floors and roofs. They're always there.
And a live load is something like people, furniture, or equipment. They're loads that can move around or change weight, maybe even mass. You also have to remember dynamic loads. They're moving loads, like, say, traffic over a bridge. Earthquake loads are loaded when a base is shaken. The response of the structure is dependent on the frequency of the motion. And when the frequencies match with the natural frequency of the structure, it resonates.
And we can't forget all the types of structures that these loads act on, like arches, planar trusses, beam girders, braced frames, rigid frames, space trusses, and cable suspended structures.
Well, since you already know about those, Godzilla, we'll move on to our last topic, the 6 simple machines. This bubble map illustrates the 6 types of simple machines: the pulley, the wheel and axle, the wedge, the screw, the inclined plane, and the lever. Now, inclined planes are flat surfaces that are higher on one end. They're made so that you can push things up them. It makes work a lot easier. You could even carry things up them if you wanted.
Like a ramp?
Exactly. If you want to know how much easier it makes work, the mechanical advantage of an inclined plane is equal to the length of the slope divided by the height of the inclined plane. And while it does produce a mechanical advantage, it does so by increasing the distance that you actually have to take the force. Next, let's talk about the screw. The mechanical advantage of a screw can be calculated by dividing the circumference by the pitch of the screw. You see, the pitch equals 1 over the number of turns it does per inch. You see, all a screw really is an inclined plane wrapped around a cylinder. Now, all wedges are 2 inclined planes joined back to back. They're usually used to split things, like, say, the end of an axe blade. That would be a wedge. The mechanical advantage of a wedge can be found by dividing the length of either side of the wedge by the thickness at the bigger end.
What about the lever?
Well, Godzilla, there are 3 types of levers: first, second, and third class. You see, the first class lever has its fulcrum between its effort and its load. The effort moves farther than the resistance. Some common examples of a first class lever are like a crowbar or a seesaw. Now, a second class lever has the load between the fulcrum and the effort, so the effort moves farther than the resistance. An example of this would be a nutcracker or a bottle opener. Now, say you have a third class lever. The effort will be between the load and the fulcrum, and it doesn't multiply force. You see, the resistance moves farther than the effort, and it multiplies the distance that the effort force travels. And you see, the mechanical advantage of a lever is the ratio of the distance from the applied force to the fulcrum to the distance of the resistance force to the fulcrum.
So, a third-class lever would be like a tweezer or a fulcrum.
Exactly, Godzilla. Now let's talk about pulleys. Pulleys are just wheels and axles with a groove around the outside. You see, a pulley needs a rope, or something like a chain or a belt, around the groove so that you can pull it and make it work. You see, a fixed pulley changes the direction of a force, but it doesn't create a mechanical advantage. It's just one wheel and axle with a rope that you put effort on one side with the load on the other. Then there's a movable pulley. You see, the mechanical advantage of a movable pulley is equal to the number of ropes that support the movable pulley. The pulley holds the load, and then you have one end of the rope attached to, say, a beam or something, and then you pull the other end of the rope. On a combined pulley, the effort needed to lift the load is less than half the weight of the load, but the main disadvantage is that it travels a very long distance.
What's a wheel and axle?
Well, you see, Godzilla, a wheel and axle is a simple machine that actually has two parts: the wheel and the axle. You see, the axle goes through the wheel so that it can spin around. The mechanical advantage of a wheel and axle is the ratio of the radius of the wheel to the radius of the axle. You could also increase your wheel and axle speed by applying the input force on the axle instead of the wheel. You see, the increase is computed like mechanical advantage. This combo could increase the speed 5 times. Now let's talk about gears. Gears are a type of wheel and axle. You see, each gear in a series reverses the direction and rotation of the other gear. The smaller gear will always turn faster than the larger gear, which means it'll have more rotations per minute.
Wow! That's great! Thanks for teaching me all this stuff about engineering, Gigan.
No problem, Godzilla. Just study these graphic organizers and you'll do just fine.
Haha, that's a good one, Gigan. See you later.
Yeah, he's hopeless.